Let's not forget that each of the events we discussed are random in nature. That is, the selection of any number is as likely as the selection of any other number. It would be useful to imagine an urn in which we have 40 marbles, 10 of each color: yellow, green, blue, and red. Each marble has painted on it a digit from 0 to 9. Therefore, x equals a red 2 means that a red marble with a 2 on it has been selected at random. Let's now move on to compound events. Compound events consist of two or more simple events. For example, for two events A and B, we could examine the probability of either event A or event B occurring, or we could examine the probability of both event A and event B occurring. However, this topic we'll save for the next video. Let's start with the probability of A or B, which is equal to the probability of A plus the probability of B, and is known as the addition rule. The examples we will demonstrate first will be mutually exclusive events. Mutually exclusive simply means that if event A occurs, event B cannot occur. Let's now explore this with a few examples. Let's let event A represent x equal a yellow 3, and let event B represent x equals a red 6. Now let's evaluate the probability of x equals a yellow 3 or x equals a red 6. The number of ways x equals a yellow 3 can occur is 1, and the number of possible outcomes is 40. So the probability of x equals a yellow 3 is 1 over 40. The number of ways x equals a red 6 can occur is also 1, and a total of 40 possible outcomes, making the probability of x equal a red 6 also 1 over 40, for a total of 2 over 40, or 1 over 20. The events of x equals a yellow 3 and x equals a red 6 are mutually exclusive because x cannot equal a yellow 3 and a red 6 at the same time. That is to say, if you were to randomly select one marble from the urn, it could not be both a yellow marble with a 3 on it and a red marble with a 6 on it. Let's now look at the probability of x equals a yellow, that is, any yellow number, or x equals a blue 6. The number of possible ways of x equaling any yellow is 10, and the total number of possible outcomes is 40, for a probability of 10 over 40. The number of ways x equals a blue 6 can occur is 1, and the total number of possible outcomes is 40, for a probability of 1 over 40, making the probability of x equal any yellow number or x equals a blue 6 equal to 11 over 40. These two events are also mutually exclusive because a marble cannot be yellow and a blue 6 at the same time. The probability of x equals any 4 or x equals any 8 is the number of ways a 4 can occur, which is 4, divided by the total possible outcomes, which is 40. So the probability of x equals any 4 is 4 divided by 40. The number of ways any 8 can occur is also 4, and the number of possible outcomes is still 40, making the probability of x equals any 8 equal to 4 divided by 40. The probability of x equals any 4 or x equals any 8 therefore equals 8 over 40, or 1 over 5. These events are also mutually exclusive because x equals any 4 and x equals any 8 cannot occur at the same time. Let's look at one more example of mutually exclusive events. Let's determine the probability of x equals any green number or x equals any red number. The number of ways a green number can occur is 10 out of a possible 40 outcomes, making the probability of x equals any green 10 over 40. The number of ways x equals any red can occur is 10, and the number of possible outcomes is 40, making the probability of x equals any red 10 over 40, for a sum of 20 over 40, or 1 over 2. As stated earlier, these are mutually exclusive events, because if a green number occurred, it means that a red number could not have occurred. Let's now look at an example where the events are not mutually exclusive. Let's look at the probability of x equals any 3 or x equals any blue. There are 4 ways a 3 can occur, out of 40 possible outcomes, making the probability of x equal any 3 equal to 4 over 40. The number of ways a blue number can occur is 10, out of 40 possible outcomes, making the probability of x equals any blue 10 over 40. We need to observe that the occurrences of any 3 and the occurrences of any blue number intersect where x equals a blue 3. This means the events of x equals any 3 and x equals any blue are not mutually exclusive, because x equals a blue 3 is both a 3 and a blue number. We counted the occurrence of x equals a blue 3 twice, once for the probability of x equals any 3, and again for the probability of x equals any blue. The addition rule needs to compensate by subtracting the probability of A and B occurring in the same event. When x equals a blue 3, we have a case where x equals any 3 and x equals any blue occurred in the same event. X equals a blue 3 occurs once out of a possible 40 outcomes. Therefore, the probability of x equals any 3 and x equals any blue is 1 over 40, making the probability of x equals any 3 or x equals any blue equal to 13 over 40. Let's now look at a similar case, the probability of x equals any 7 or x equals any green. X equals any 7 can occur 4 possible ways out of a possible 40 outcomes, making the probability of x equals any 7 4 divided by 40. X equals any green can occur 10 possible ways out of a possible 40 outcomes, making the probability of x equals any green 10 divided by 40. X equals any 7 and x equals any green can occur at the same time where x equals a green 7, which can occur once out of a possible 40 outcomes. Therefore, the probability of x equals any 7 and x equals any green is 1 over 40, making the probability of x equals any 7 or x equals any green 13 over 40. Let's look at one more example. Let's evaluate the probability of x equals any odd number or x equals any green number. The number of ways x equals any odd can occur is a total of 4 1s, plus 4 3s, plus 4 5s, plus 4 7s, plus 4 9s, for a total of 20 out of 40 possible outcomes, making the probability of x equals any odd number 20 over 40. The number of ways x equals any green can occur is 10 out of a possible 40 outcomes, making the probability of x equals any green 10 divided by 40. We need to now determine the probability of x equals any odd and x equals any green by first determining the number of ways a marble can have an odd number and be green. Of all the possible ways an odd number can occur, 5 of them are green out of a possible 40 outcomes, making the probability of x equals any odd and x equals any green 5 divided by 40. Therefore, the probability of x equals any odd or x equals any green is 25 over 40, or 5 over 8.